Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article, a WebAssembly compiler that fits in a tweet. It's incredibly compact, a mere 192 bytes. Can you believe it?
Whoa, 192 bytes? That's mind-blowing. I'm already intrigued. What exactly does this tiny compiler do?
It compiles arithmetic expressions written in reverse Polish notation, or RPN, into a valid WebAssembly module. The module then exports a single function that calculates the result. Think of it as a super miniaturized calculator, all within WebAssembly.
RPN, you say? That's a bit unusual. So how does this 192-byte marvel actually work? It must be heavily optimized, right?
Absolutely. The authors used a bunch of clever tricks to minimize the code size. They started by using JavaScript's assignment expression as an expression itself, cleverly reusing variables and avoiding extra statements. They also used sparse arrays, representing zeros with empty array elements.
Sparse arrays, clever. So they essentially handcrafted the WebAssembly bytecode directly?
Precisely. Instead of using a library to generate the WebAssembly, they wrote the bytes directly into an array. This is a trade-off, of course. It's less maintainable, but it drastically reduces the size. They even used single-letter variable names and reused variables to save bytes.
Wow, that's some serious optimization. But how readable is the original code? I imagine it's quite cryptic.
You're right. The original code is extremely obfuscated. The article meticulously deobfuscates it step by step, making it progressively more readable. They replace single-letter variables with descriptive names, remove assignment expressions, and add back the missing zeros from the sparse arrays.
So it's a case study in code optimization and WebAssembly internals? I see. What other tricks did they employ?
They used tagged template literals for string splitting, a ternary operator for conditional logic, and even a clever trick with index OF to generate WebAssembly opcodes. They also had a clever idea that almost worked, involving UTF-8 character codes, but it ultimately didn't pan out due to inconsistencies between character ordering and opcode values.
Fascinating. It sounds like a great learning opportunity. Did they explain the WebAssembly bytecode in detail?
Yes. They provided a commented version of the bytecode array, explaining each section: the magic number, version, type section, function section, export section, and code section. It's a great way to understand the structure of a WebAssembly module. They even discussed the limitations, such as the handling of numbers only up to 63.
Only up to 63? That's a significant limitation. But it's understandable given the size constraints. What's the overall takeaway from this article?
It's a testament to the power of optimization and a fantastic resource for learning about WebAssembly. It shows how much you can achieve with a small amount of code and a deep understanding of the underlying technology. It also highlights the trade-offs between code size and readability. If you're interested in a deeper dive into WebAssembly, the authors recommend their book, WebAssembly from the Ground Up.
Definitely sounds worth checking out. Thanks for summarizing this amazing article.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.